So we will go ahead and get started. I've answered a couple basic questions there from you guys. Anybody else have any other questions or extended questions on those that we've already discussed? WebWork 16, problem 8. Okay, I will address that at the end of class. Since we haven't gone through section 16 yet, I want to at least talk about it first, but we will definitely hit that before we end the session today. I will write that down if I can find a piece of paper. Okay, so WebWork 16, number 8, we will talk about at the end of class. Anybody have anything else from 15 and earlier? I don't know if everybody saw my announcement this morning, but I have extended WebWork homework 14 and 15 to be due on July 5th at midnight. So that gives you actually a couple extra days. People are having a lot of problems with that. I got quite a few emails. And because of that, I have another live session Wednesday, and I know that we don't have class tomorrow because of the 4th, but I wanted to give them some extra time as well. So I just made Thursday the due date for those. So hopefully if we can get a couple things out of the way today, get a couple extra problems done, that might help. Okay, so anything else besides WebWork 16, problem 8 that we'll do at the end? Anything else? No? All right. Well, in that case, we'll go ahead and get started. So you'll notice that this week, we're going to review section 15 first. I've got 3 problems that I want to work through just to kind of reiterate the goal of section 15. Then we have section 16, 17, and 18, which get into probability and then margin of error. So due on Monday, Friday, crap, what are my due dates here? Let me see. The 6th, that's Friday. So due Friday will be section 16, 17, 18, the quiz and the discussion board. So these 3 items are all due the 6th, and then we get ready for exam 2. So exam 2 is due no later than the 13th. But remember, this class ends on the 27th. That's the last day you can turn anything in. If you wait until the 13th to take the exam, you have exactly 2 weeks to do the entire 3rd unit. So I would recommend, if possible, take exam 2 maybe midweek next week so that you have time to get started in there. Along with that then, so next week, which is the 9th, our live session will be questions about the exam. And it's slated, so we'll do questions. I don't really want to do a live session about Unit 3 before people have taken the Unit 2 test. To me, that's just too much going in. So I will post an extra live video about sections 19 and 20, but I do not want to talk about that. I don't want you to start Unit 3 before you have finished Unit 2, if that makes sense. Now, if you come to the live session and you're the only one there on Tuesday, and you're done with the exam, we can talk Unit 3 all you want. But to me, that's just a lot of confusion when we're starting to throw in financial things before you finish. So, okay, any questions about any of that? Our goal of what we're doing today? Okay, so remember with exam 2, you have that practice exam. I know a lot of you have played with it extensively for exam 1, and hopefully you see the benefit. So we can keep with that moving forward. Okay, moving on. Oops. Okay, so section 15 kind of gets us into probability in a different way. So section 16 and 17 deal with pure probability. In 15, you're dealing with probability, but you're dealing with it from a z-score perspective. So the hours of TV watching is normally distributed with an average of 85 minutes and a standard deviation of 12 minutes. What is the probability someone watches TV less than 70 minutes? And if you just read this question and you're trying to find an answer, it's very difficult. So what I think, things are being normally distributed. That means we have this curve. Now, the average is 85, which means that's right down the middle, right? We've talked about that. The average is 85. So when it says probability that somebody is less than 70, well, 70 is to the left of 80, right? Because it's less. And we want less than that. So we're looking at the area to the left of a value of 70. And remember, probability is area under the curve. And that's all well and good, except if you look at your probability table, that's on your yellow sheet, page 246, 70 is not on there, right? Because 70 is a value, and we're not looking at values, we're looking at z-scores, right? That table to find probability needs z-scores. So that's hopefully when you see probability, you think, okay, if I use the probability table, I have to have a z-score. And a z-score is the value minus the mean over the standard deviation. So the value in question is our red 70, our mean is 85, and our standard deviation is 12. So we have negative 15 over 12, which should be what, negative 1.25? Oops, wrong button. Just want to double check myself. Yep. Okay, so we're at negative 1.25. Now, if you look at your table, we have negative 1.2 or negative 1.3. And because we're at 0.5, you really can go either one. I'm going to go ahead and just round to negative 1.3. So the z-score associated with is negative 1.3. That gives me just, now I can use my table. So when I find a z-score of negative 1.3 on my table, the area to the left is 0.0968. So the probability someone watches less than that is 0.0968 or 9.68%. I know there's one problem in WebWork that says 3 decimal places, so the answer would be 0.097. Right, you got to make sure you're paying attention to the details of all of the problems. All right, and I don't know if you guys are all having issues with 15 or if just people who emailed me, but I figure might as well do a couple problems and people can watch it later, or, you know, you never hurts. Okay, I would like you guys to try this one, and then we'll talk about it. The hours of TV watching is normally distributed with an average of 85 minutes and a standard deviation of 12 minutes. What is the probability someone watches more than 90 minutes? Yeah, that's the right answer in the chat box. So let's draw it up, because I'm a big fan of visualization. So again, we have our normal distribution. When you're doing these problems, if you are a visual person or if you find yourself struggling, you should be drawing pictures for every one of these. Okay, the average is 85 in the middle. So when they say more than 90, 90 falls to the right of 85, and more means to the right. So I'm finding this area over here. Again, I need a z-score. So the z-score is the value, which in this case is 90, minus 85 over 12. And when you get 5 over 12, your calculator is going to spit out at you 0.42. Well, if you look at your table, 0.42 is not really an option, so closest to is 0.4. So here's the z-score associated, 0.4. When you look at that, you get 0.6554. Remember, the table always gives you area to the left. So to find the area to the right, we take 1, which is the whole thing, and we subtract 0.6554, which gives us 0.3446. So the probability someone watches more than 90 minutes is 34.46%, or 0.3446. Okay. And one more for review from this is a slightly different type of a problem. And hopefully you guys will stop me if you have questions. But the hours of TV watching, same thing. If Billy thinks he is in the top 20% of TV watchers, how many minutes of TV does he watch? So now we are trying to find X. But think about what they give us. Okay, we still know normal distribution. So we still have the curve. And we have Billy. He thinks he's in the top 20%. So if I make a line and say, okay, this line is Billy. If he's in the top 20%, that means this is 20% over here. Well, if the top 20%, what does that make the left portion? If the top is 20%, what's the bottom? $80, exactly, because the whole thing is 100%. Okay, so remember, area under the curve is probability. So 80% is the same as 0.8. Well, if you look at the table, probability table, now we're kind of working backwards. So we look at the probability line, and you're looking for 0.8. And the closest probability I can find to 0.8 is 0.8023, and it has a z-score of 0.85. That is the z-score associated with the 0.8023 probability. Because we need, remember, we're using the z-score formula, value minus mean over the standard deviation. So once I have my z-score, I've got 0.85. I don't know my value, but I know my mean is 85 and my standard deviation is 12. What did I just hit? There it is. I really don't know what I hit. Okay, so what is our next step in solving this equation? Because remember, the equal sign splits it up equally on both halves. What's my next step to solve this? We do need to get x alone, absolutely right. There are 2 steps to do that. What's step number 1? Multiply by 12, absolutely. We want to get that fraction out of there, so we multiply both sides by 12. So if you think multiplying by 12 over 1, the 12 will reduce. We're just left with x minus 85. And then I take 12 times 0.85, and I get 10.2. And then what's step 2? Add 85. Yep. You're always doing the opposite of what you see. So that gives me x equals 95.2, and this is minutes of TV. All right. So that's kind of another way to use the z-score probability table to do some problems from that section. Okay, so hopefully that was a little bit more of a review. Sometimes it just helps to see a couple more examples. But if something is normally distributed, if you have a mean, a standard deviation, a value, you're finding z-scores to get to probability. You really just, math is about seeing what they give you and then letting it kind of take you from there. So what do you have and where can that take you? All right, there's a good question to go. Okay, any other questions from section 15? Or 14 for that matter. 14 or 15. Otherwise, we're going to jump into section 16 and get into probability. Okay. So probability, by definition, is just a chance that something is going to happen. And we've already been talking about probability with our z-scores. So remember, probability, you can write it as a decimal, as a percent, or technically you can even write it as a fraction. We generally don't leave things as fractions very often because then you have to reduce, and that sucks. I mean, it's not fun, especially when you're dealing with big numbers. So we tend to start as a fraction, almost always we'll start it as a fraction, and then we change that fraction to a decimal or a percent to kind of go from there. So, okay, so the rules. Probability must be between 0 and 1 inclusive. And what that means is if we have a probability of 0, right? That means it can't happen. Like it's totally impossible. It will never happen. No. The probability of 1 means it will definitely happen. Like, what is the probability you're going to have an exam next week? 1. I mean, it's scheduled. You're going to have it. Whether you take it or not is up to you. But the probability that you're going to have an exam in this class next week is 1. It's definitely going to happen. Okay. The sum of all probabilities must be 1. And this is what I mean by that. Let's talk about flipping a coin, right? If you flip a coin, you're either going to have heads or tails. The probability of flipping a heads is 1 out of 2 because there are 2 sides on the coin and one side is a heads. The probability of flipping a tails is also 1 out of 2 because there are 2 sides and one of them is a tails. So if you add those together, you get 2 over 2, which is 1. Because if you take the heads and the tails together, that makes the entire coin. So that's what that rule means, is that if you add all of the probabilities for a certain event, in this case flipping a coin, the probability will be 1. And the last rule is basically just the definition. The probability of an event is the number of ways it can occur over your total possibilities. So I talk about it as what I want to have happen over my total possibilities. That's kind of how I think about it. What do I want? That's my numerator. All right, so there's your basic background definitions of section 16. So let's move into some problems. First one, very basic. We're rolling a 6-sided die. What is the probability of rolling a number greater than 1? Okay, what do I want in this problem? What am I looking for? Greater than 1. Absolutely. So think about a 6-sided die. How many numbers are greater than 1? 5, exactly, because there's 2, 3, 4, 5, and 6. So there are 5 numbers greater than 1, and there are 6 total sides. So as a fraction, my probability is 5 over 6. Let's go ahead and change that to a decimal. Let's go 3 decimal places, please. Let's do that for today. Let's go everything to 3 decimal places. Good. Rounded appropriately, 0.833. All right, so that's kind of a basic probability. Most of the stuff we do in here deals with probability tables, this being a probability table. So you'll notice that we have a total column on the right, so the males added together, and then we have totals across the bottom, which would be the colors. So, and then this 80 is the overall total, right? We have 80 total people here. So we're going to use this table, I think, quite a bit in answering some questions. So first things first, what is probability somebody likes red, right? So we're looking at the reds over the total, and yeah, I picked the red pen on purpose. So how many reds do we have? Because probability is really about paying attention to details, right? We want somebody who likes red out of the total, because it just says someone. It's not specifying, it's talking about everybody. So 18 over 80, let's go to 3 decimal places. Okay, oh, there it is. 0.225. Yeah, don't add too much. Just here's red, here's the total, there's my fraction. Boom. You can change that to a percent if you'd like. We're just going to go decimal for our work here today. Okay? So go ahead, give me a fraction and a decimal. What is probability that someone is a female? Fraction and decimal. So we're looking for a female. Female over total. How many total females are there? 40. How many total are there? 80. So we end up with 40 over 80, which is 0.5. Okay, does that make sense? Oh, button. So, all right. Good, good. Yeah, if you just leave it as 40 over 80, that would be wrong. You could reduce that to the fraction of 1/2. That's why we just change it to a decimal. It makes it a little bit easier. Then you don't have to worry about reducing fractions. All right. Now let's look at this one a little bit. We're getting into some conditionals or some extra pieces. So what is the probability of choosing a male who likes purple? So now we want a man and he's got to like purple. So we look at the male column. We look at the purple column. How many men like purple? 10. So we want men who like purple, and we're choosing that, right? A man who likes purple is 10 out of the total, which is 10 over 80, which is 0.125. And some of probability can be a little bit tricky. So, don't fret if it takes you a couple tries to kind of see where the numbers fit. Okay, or is where we get into, well, you say that now. Not all probability is beautiful. Okay, probability of a female or somebody who likes red. Now, there are two ways to do these problems. I'm going to show you both ways. It depends on how you are given data or the size of your table. So or implies either one. But look how this works. So I want female and the red, right? So if I look at females, that's this column. There are 40 total females out of 80. Then if I look at the red column, there are 18 people who like red out of 80. But what do you notice about that? We counted these people twice, right? They got counted as part of the female total. They got counted as part of the red total. So we say we subtract the overlap. So when I see or, that tells me to add and subtract the overlap. Okay. Which should give me 52 over 80 or 0.65. Okay. I prefer to do it this way, where I add the two totals and subtract the overlap, because that's going to work no matter how your data is presented. Big table, small table, no table. That will always work for an OR problem. Okay, so you add the two totals and you subtract the overlap. Now, the other way is simply to just look at your table and say, okay, I need all my reds and the females. And you just work on the inside numbers. You don't work with the totals at all. So if I would add these four pink numbers together, I would get 52 over 80. Some people like the counting way better. That works until they don't give you a table. If they don't give you a table, you kind of get screwed. So that's up to you. Okay, but the OR problems generally are the hardest. Okay. You guys doing okay? Making sense? Okay, this last one is what we call a conditional. Up to this point, we've always been out of the total. But this one changes that. What is the probability of choosing someone who likes blue given it is a female? If you see the word given, or sometimes they use the word if, that tells you we don't care about everybody. We only care about a small piece. So in this case, given we have a female. So they say, you know what, we only care about the females. That means in our fraction, the denominator will be the females, and the top will be females who like blue. So when I look at this, the total number of females is 40. When I look out of all of the females, 26 of them like blue, right? Because I'm focused on just that row. And that gives me a decimal approximation of 0.65. Okay. So if you see the word given or the word if, either one of those words, whatever follows it becomes your denominator, because that tells you the whole group that you're looking at. That's everybody you want. Okay. Okay, questions over any of those? Those are the straightforward probability problems from section 16. So section 16 should be straightforward probability. Asking you questions like this, given a table or words, and you having to come up with a fraction, change it to a decimal, round appropriately, that kind of thing. Questions on 16? Besides number 8. Rochelle, I haven't forgotten. We will totally go to WebWork after we're done with 18 and look at number 8. I promise. I will not leave you hanging. Okay, so now with no questions from 16, we move into section 17. Now, mathematically, section 17 is just an extension of 16, where we are going to get into false positive, false negatives, but we are going to create our own probability table. So looking at this, we're going to be given a table, and actually in WebWork, they're not going to give you a table. You're going to have to draw your own, but you're going to create your probability table first, and then you're going to answer questions about it. So have you guys ever heard of false positives or false negatives? Yeah. If you've been in the medical world at all, you probably have, because that tends to be the majority of where this stuff comes from. Incorrect tests and that kind of thing. So basically, once you get your head around it, it's great. Sometimes it just takes a little bit to get there. So false positive. You test positive, but it's incorrect. So you go to the doctor and they say, hey, you're pregnant. And then you find out 3 weeks later that, no, you're not. Just kidding. Right? So you tested positive for pregnancy, for strep throat, for, I don't know, Crohn's disease, anything that they can test for. You test positive, but it's incorrect. Okay. The other side of that is a false negative. When you test and it's negative, so you think you're fine, but it's wrong and you actually do have that disease. So the example, you're told you do not have strep throat, but you totally do. So they say you're fine. They don't give you any antibiotics. You go home and you're miserable for more weeks, right? This is kind of the world that I'm living in. So I've had stomach issues for years. This is a lot of information. And they did a ton of tests back in January, one of them being a celiac panel. And it came back negative. But the results were so odd, like negative to the point where they've never seen numbers like that my doctor said, okay, we're going to do some stuff for about 12 weeks. Actually, it's been longer than that. And then we're going to come back and we're going to do this test again because it just doesn't seem right. So she thinks it's a false negative. I'm hoping it's a true negative because nobody wants celiac. So I'll be doing that blood work next week, right? So sometimes if you have a false positive or a false negative, they will come back maybe and do a second test to double check things, right? Think about drug tests. If you get drug tested and it comes back positive in a workplace, they more than likely they will do a second test to double check. And we're going to show why that is when we get to these tables on the next piece. Okay, any questions about the definition of these things? Right, a false positive means you tested positive, but it's wrong. A false negative means you tested negative, but it's wrong. So whatever the false part is, that's how you tested, and the false means it was wrong. So once you wrap your head around that, it's not too bad. Okay. To do the questions in WebWork, you are going to need to create a table for each problem. And there's nothing exciting. You have you either have it or you don't. You tested positive or you didn't, and you have your total columns. That's all you need. If you get stuck on a WebWork question and you email me for help, I need you to snap a picture of your table and send it to me. Because without seeing your table, it's very hard for me to help you without just giving you the answer. And I'm not a huge fan of just giving you the answer. So snap a picture of the table, shoot it to me in an email and say, number 7 is driving me nuts. Here's my table. And then I can say, hey, you added wrong, or you multiplied wrong, or where are you getting your numbers? And I can talk you through it a little bit easier. Okay, so 3% of people are allergic to snakes. By the way, this is completely made up data. A test with 92% accuracy can be used to test for this allergy. Use a sample of 50,000 to create a table and answer questions A through D. All right, I need you guys to do this table on your own. That way, when we go to the other questions, the table's going to be gone, but you will have it in front of you. Okay, so the thing is, you always need to do the total column first. You can't do anything in the middle without the total. So they tell us to use 50,000. And this number is meaningless. Because we are dealing with percentages, you could start with 5 and you'd get the same answer at the end. Like for our probability answers, it would be the same. So that those numbers are not super duper important. But we're starting with 50,000. Now, do you have any idea how we're going to get the has allergy or does not have allergy? Based on the information they gave us, any idea where to go from here? Read through the problem. Think about it. 3% have the allergy. Exactly. So if we have 50,000 people total and 3% has the allergy, that's this part, right? So 3% of 50,000. What does of mean in math? Of means two. Oh, denominator. You could totally set that up as a proportion. Yeah. So 3 is 3 over 100 is over of. Yep, that's one way to do it. Or you could do 3% of is to multiply, and you could multiply by 50,000. Either way, you get the same answer, which is 1,500. I really wish this feature had an erase button. That would be awesome. But it's all or nothing. I don't like that. Okay, now you guys know how to do this one. If you started with 50,000 and 1,500 have the allergy, how do we figure out how many do not have the allergy? Yeah, you subtract. Take the total 50,000, subtract 1,500, and so we know that 48,500 do not have the allergy. All right, super good, super good. Now we're ready to play on the inside. So the totals come first, then we go to the inside. And the inside 4 is where the accuracy rate comes in. And guys, this is where your common sense has to shine through. Okay, so think about this. Let's pretend you are allergic to snakes. Seriously. If you go to the doctor and you know you're allergic to snakes and they test you for it, how do you expect to test? Positive. Exactly. Makes sense. If I have the allergy and they test me for it, I'm going to test positive. Great. So the accuracy goes where it's supposed to. So where I put that little pink X, 92% of people who have the allergy will test positive. Well, we know that 1,500 people have the allergy, right? Because that's our total. So 92% is 0.92 multiplied by our 1,500. How many out of those 1,500 are going to test positive? 1,380. Stop me if you don't know where these numbers are coming from. We call this a true positive because you have the disease and you tested positive for it. True positive. Okay, now same kind of idea. If you have 15 people who have the allergy and 1,380 of them test positive, how many of them test negative? Yep, already subtracting, and we end up with 120. What is that number called? That works. All right, we'll come back to the definitions. Let's go to the does not have allergies. If you don't have the allergy and you go to the doctor and they test you for it, how would you expect to test? Negative. Exactly. See, this is where your common sense comes in. I don't have the disease, I should test negative. Okay, or the allergy, whatever you want to call it. So 92% of those who do not have allergies to snakes will test negative. So 92% of 48,500 will test negative. How many is that? 44,620. Good. And again, we call this a true negative because if you don't have it, you should test negative. And how many will test positive? You had 48,500 who do not have the allergy. 44,620 of them tested negative. So how many will test positive? Good, 3,880. Okay. After we're done with the inside four, so the inside four, again, is where the accuracy comes in. Now we're ready to total them up. So how many total positive tests do I have? It is not 2,500. You got to vertically add 5,260. There we go. And then we vertically add this one, and we should get 44,740. And double check that your bottom two totals add up to be 50,000, because that's what you want to have. Oh, yep, that will do it if you subtract it instead of add. Absolutely. Okay, so we now have ourselves a probability table. Using the information they gave us, we were able to create a probability table. Okay, anybody have any questions on where those numbers came from? How do you know which side to multiply? What do you mean which side to multiply? What do you mean by which side?
I was just looking at the thing, just like trying to figure out the positive with the negative. You multiplied the positive test with the 92%.
Yep, you're always gonna multiply the accuracy rate that they give you times a total. So you're going to do that twice, right? Because you're multiplying the positive by the positive total. So it's going to be multiplied by the 0.92, and this one's going to be multiplied by the 0.92. The deal is you've got to know where to put them. So that's where the trick comes in. Where if you have the allergy, so the top line, if you have the allergy, you expect to test positive. So after you multiply the 1,500 times 0.92, that goes in the positive because that's what you expect to have happen. And with the not have allergy, well, you would expect to test negative. So after you multiply your total times 0.92, you expect to test negative. So that's where you put that number.
Oh, that makes sense. Okay, thank you.
Yep, good. And then to get the other pieces, we simply subtract, right? So you had your total, you subtract what you had out, and it's whatever is left. It goes in the other two places. Yep. So the spot where you see the X's, the pink X and the green X, those are the true tests. I had the disease and I tested positive, or I don't have it and I tested negative. So that's where the 92% number comes into play. And you're always multiplying it by the total. Yep, good question. Okay. So now so I have my table up, but you don't get to see all of the labels here. How many false positives are there? So we're going to do that one in yellow. So false positive, what does it mean to be false positive? It means you tested positive, but it's wrong, right? So tested positive is this column, all right? So how many false positives? Well, there's 5,260 of them total, so that's my denominator. Which one of those numbers, 1380 or 3880, which one of those is wrong in this column? The 3880, yep, because the 1380 is the true positive, right? Because if you have it, you expect to test positive. The 1380 are the ones who have it that tested positive. The 3880 are the they don't have it, but they tested positive. That's wrong. If you don't have it, you shouldn't test positive. Hence the false piece. So, oh, it didn't say write a probability. It just said how many. There are 3880 false positives. What about how many false negatives are there? So false negatives means they tested negative. So now we're in this column. They tested negative, but it's wrong. So how many of that? There's your 120. Yep. Because tested negative, but you actually have it. So that's wrong. Yep. Okay, so it's good to be able to recognize false positive, false negatives. Given a positive test result. Okay, this is back to our probability from section 16. Given a positive test result, that means we're only looking at the positive row, the 1380, the 3880, and then the total 5260. So given a positive test result, what is probability someone does not have the allergy? Okay, well, since we're given a positive test result, the total positives is my denominator. What's going to be my numerator if we want somebody who does not have the allergy? 3880. So that's the problem I started to do before until I realized I don't know how to read. You know, minor details. What is 3880 divided by 5260? Let's go to 3 decimal places still. 0.738. Good. Good, good. Okay. So really, if you think about it, once you have your table, then it just becomes a probability problem. But if you don't have your table correct, you can't answer the rest of these problems. That's why the table is kind of the crucial piece, and why I said if you have questions, just take a picture of the table and get that to me, because we really have to make sure that's correct before we can move on to anything else. Okay, try this one based off the table in front of you. Given a negative test result, what is the probability somebody does have the allergy? Let's go fraction and then decimal to 3 places. Dakota, you're close. I think you rounded incorrectly. Either you did or I did, which I guess that could be a toss-up. Okay, so there you go. Okay, so as soon as you see the given, right? Given negative test. So that means we only care about those negative testers. So our denominator is 44,740. What is probably someone does have the allergy? Well, how many of them do have the allergy only looking at that column? Well, just 120, right? So we have that super small fraction, 120 over 44,740, and then rounded to 3 places, as Dakota mentioned, is 0.003. So a 0.3% chance, right? So if you multiply that by 100%, 0.3% chance that if you test negative, you actually have it. So you can probably feel pretty good that if you test negative, you actually are negative. That's a good feeling. Okay, how do you feel about section 17? Because that's false positive, false negative. I will tell you. Okay, so we just did what I call a straightforward example. It's got a probability, you know, there's nothing too trickery about it. When you get to WebWork, and I know you guys love WebWork, there are, I would say there's maybe 2 or 3 problems that are a little tricky. They add a little bit of something else in there. And so you got to really pay attention to the details. Don't forget the help videos, because I think there's a help video for every problem in section 17. So remember, if you get it wrong 3 times, the help video will show up, and that doesn't count against you to get it wrong. So you might as well try it to get those videos if you need them. But otherwise, right, send me a picture, and I'll be more than happy to help you. Okay, so let's go to section 18. By the way, section 18 has nothing to do with anything that we've done so far. It is like random out of nowhere. But we're going to do a problem. The next slide is basically the basic exact thing you're going to see on the exam. Okay, pretty much, I mean, obviously it'll be a different problem, but the series of questions, almost identical. So if you can kind of get your head around that, you should be okay. So pay attention to the problem in class. I mean, WebWork practice and that kind of thing, but it's pretty good here. Okay, so here's the deal. Section 18, which is titled Margin of Error, deals with polling. So, when we have a presidential election, they go out and they ask questions, who would you vote for? Okay, so that's kind of what this is all about. Or they go out and they do a survey on, what social media site do you use the most? Whatever. All these dumb polls that are done all over. So the first thing with this is talking about a population versus a sample. Now, a population is all the possible people you could have talked to. So if we're talking about the presidential election, right, everybody 18 and older who is registered to vote can vote. You think about a country of 320 million people, we probably have 200 million registered voters. Do you think it would be possible to talk to all registered voters in the United States to do a poll? Doubtful, yeah. And even if it was possible, think of how expensive that would be, because you'd have to pay somebody to do it. You've got all that time tracking these people down. So your population is all the possible people, but as Isidoro said, it's very doubtful that that's ever going to happen. So the sample is the number that you actually talk to. So the key, the difference between a population and a sample is that the population should have the word all in it. All adults, all registered voters, all teens 13 to 17, all kids in Becky's math class. Whoever you're polling, the population is all. When you talk about a sample, you're going to have an actual number. 17 people in Becky's class, 4,000 registered voters, 200 Colts fans, whatever it is. So a sample has a number, the population has the word all. There's your key. Okay. Now, because we don't talk to everybody, we have a margin of error. And the margin of error is the variation in response by definition. Okay. Variation in response. So I'm sure you've seen this. If you watch the news during election time, they have them up. Trump versus Clinton, 46% to 48%, plus or minus 4%. Right? They got that plus or minus up in the corner, and that allows for the margin of error. We think we could be off by this much. And usually the margin of error is based off of the sample size. And we actually do have a formula for this. The formula is 1 divided by the square root of n, where n is the sample size. Okay, so the bigger your sample size, the smaller your error. And that should make sense, because the more people you talk to, you're going to get a better representation. It's going to shrink your error. Now, with all of this being said, we do all of this with 95% confidence. So this is a 95% margin of error. And what this means is that we are never 100% sure. Even if we say, plus or minus 4%, we could still be wrong. So we have a 95% confidence level, meaning we leave that 5%, we could still be wrong. If you take a straight statistics class, you can do confidence intervals of any confidence level you want, up to 99%. You might even be able to go higher than that. But in this class, because we do a very, I don't know, watered down formula of 1 over the square root of n for the sample size, or for the margin of error, we only do 95% in here. Okay, so we are 95% confident with this sample size. And so the confidence interval that we are going to find is going to be our percentage estimate, and this will make sense when we actually have a problem. And then you're going to add and subtract your margin of error. So just kind of off the wall here, if I say 40% of students love math, plus or minus 3%, well, to find my confidence interval, 40 minus 3 is 37%, 40 plus 3 is 43%. So my confidence interval would be 37 to 43% of students like math. That's what that would, that's kind of what the confidence interval means. It gives us, if we would go out and do this poll again, we would expect the data to be somewhere between 37 and 43%. That's the purpose. Okay, so that's the background. That's a lot of words. Now we're going to do an example with 5 parts, answering all of these, using all of these pieces to answer questions. Okay, so a recent survey of 2,400 U.S. adults found that 36% of adults think the Cubs are overrated. And of course, this is made up data, and I am a Yankees fan, so I don't like the Cubs. I think they're overrated. Okay, so first things first. Population and sample. What is the population here? The answer is not 2,400. Not for the population. Remember, the population is all the people we could talk to. All of them. So it would be all U.S. adults. Yep, you've got to make sure you keep them different. They're separate. So the population is all the people I could talk to. I could talk to all the U.S. adults and ask them, do you think the Cubs are overrated? The sample is the actual number, 2,400 U.S. adults. Right? So the population has the word all. The sample has the actual number. That's the difference between those two. Okay. Then we get to estimate the margin of error. And I believe the 1 over the square root of n is on your yellow sheet. I don't happen to have a yellow sheet on my desk. I think I left it on my couch. So that's unhelpful. But 1 over the square root of n. What is my value of n? Remember that n is the sample size. So we would take 1 over square root. What value am I going to put in for the square root? %36 is our point estimate. This n is just your sample size. That's where the 2,400 comes in. Because you've got to do the sample size is going to tell you how big or small your error is. We're going to get to the 36% in just a moment. No problem, no problem. So 1 divided by the square root of 2,400. There's 2 different ways you can do this. Some calculators will allow you to just type it in exactly like you see it. 1 divided by square root 2,400. The other one, some calculators, you might actually have to find the square root of 2,400 first, and it's roughly 48.99. And then take 1 divided by that. Either way, you should get about 0.02, which is about 2%. Okay. Everybody okay with that? Doing the math? Yes, no. I've only got one person responding, so I'm just going to keep going. Okay, so if we have a margin of error of 2%, when we talk about the confidence interval, this is where the 36% comes in. So the confidence interval is, okay, my estimate is that 36% think the Cubs are overrated. So the confidence interval would be 36% plus or minus the 2%. Right, because the margin of error. So point estimate plus or minus the margin of error. So if I take 36 and I subtract 2, then the low end is 34%. If I take 36 and I add 2, the upper end is 38%. So my confidence interval is 34 to 38%. Okay. Once we have our confidence interval, we can use our statement to write a statement. And when you're writing these statements, there's a couple pieces that you kind of need to make sure you have in there. So first of all is how confident are we? Well, remember that we are always 95% confident. So we are 95% confident. Whoops, I forgot my N, forgive me. We are 95% confident that between, and this is where my confidence interval comes in, between 34% and 38% of U.S. adults, because that's who we talk to. And then what are they doing? Well, they think the Cubs are overrated. So you see we've got 4 pieces to this. 95% confident, confidence interval, population, and what are they doing? Those are the 4 pieces that I'm looking for when we're looking at those, when I look at that statement on your second exam. Okay, because I'm pretty sure it's on there. Like you're going to have to write a statement using a confidence interval. Okay. And you're always 95% confident. That is never in question. So 95% confident that between 34 and 38%, right, that's my confidence interval. U.S. adults, because it's all U.S. adults. This is saying if I went out and I did another survey of U.S. adults, I would expect 34 to 38% of them to tell me that the Cubs are overrated. Okay. Whew. All right. Questions about that? Questions about anything from today? Okay, because the other half of, I don't know, I guess the live session would be for the next piece, which is exam 2. So, you know, for Friday, you have a couple WebWork sections to do, a quiz, and a discussion board. And then next week you have exam 2, which also means you've got the review quiz to do. So that's all I have in terms of new stuff. So Isidoro has no questions. Does anybody else have any questions? Okay, in that case, I'm going to switch over. Rochelle, can I get permission from you to use your WebWork so I can answer your question? Perfect, thank you. I'm going to hide my screen for a minute because I don't know what's up. And if I have grades up, that's a FERPA violation. So I'm going to just close my screen for a moment while I bring up our course. So if you could just give me one moment. 42 WebWork. There it is. Okay, and you're back. So we're looking at homework 16, number 8. You didn't even try it yet. Okay, this is empirical probability. During the past year in the maternity ward, some males were born, some females were born. It's representative. So probably it's going to be a boy. So you're looking at, you want it to be a boy. but it's got to be out of the total. So what are you going to have to do first before you can do this problem? Because they give you, here's the boys, here's the girls, but they don't tell you the total. Yeah, you're going to have to add them together. So if you add these two numbers together, that will give you the total, which will be your denominator. And I know it says express your fractions as reduced to lowest terms. I think if you just type the fraction in exactly like you see it, I think it'll count it right. Yeah. So that's just what you're looking at. Have you tried to just type it in, the 716 over the total, whatever the total is? 1545. Yeah, I would just type this in exactly like I see it. You know, they're not both even. 10, 15, 7, 7. They're not divisible by 3, not 5, not 7, not 9, not 6, not 11. I don't, if they're reducible by something, it's horrible. I would just type in exactly what you see there and see if it counts you right. Because a lot of times, even if it says that in WebWork, it doesn't really mean it. But if it doesn't work, we can work on reducing from there. But I think that's, yeah, I think you'll be okay. And I don't think that's reducible. No. Oh. Right. There's nothing else new. So don't forget, you do have to schedule an exam for next week. Oh, good. They're both right. Perfect. Perfect. So you do have to schedule an exam for next week. So make sure you do that. Following the schedule now link or whatever from before. If you have questions, of course, let me know. But if you guys don't have any other questions, I'm done for the day. So that's a quick class. I'll see you guys next week. We'll have one. Yeah, I'll answer questions about the exam, and if anybody wants me to start Unit 3, I will. Because you do have sections 19 and 20 due on the 16th. But I can just post extra videos for those too. So it's kind of an optional session next week, I would say. If you have questions on the exam, that will be our main focus next week. And if we do anything new, I will record it and post it. So, yeah. Okay. All right. Well, I'll stick around for a few minutes in case anybody needs anything. Otherwise, have a great week. And of course, keep emailing me with your questions, and we'll get ourselves through these couple more weeks. Keep working. Thanks, guys.